Good evening and welcome to day 2 of the Tamil Heritage Trust Indology Festival 2020. Thank you very much for joining us today, and we hope you'll stay with us for the rest of the week as well. Today we have 2 talks by experts on India's prehistory and India's early history, the Harappan period. But before we get there, a quick word about Tamil Heritage Trust for those of you who are new to THT. Tamil Heritage Trust is a not-for-profit trust based in Chennai. It was established in 2010 by a group of friends from diverse backgrounds, but with a shared passion for Indian heritage. THT's objectives are to help document, understand, appreciate, disseminate, and celebrate the various aspects of India's wonderful heritage. Through our monthly heritage talks, we offer a platform for the expert and the well-informed enthusiast alike to share their knowledge on a wide range of topics: history, archaeology, epigraphy, numismatics, art, temple architecture, and so on. We also conduct workshops for heritage lovers. Some of them are how to see a temple, the Mallai study tour, and the short course on Pallava Grantha, and so on. During Chennai's famous music season, or Kacheri season, we conduct a Pechu Kacheri, that is a concert of talks. This is a 2-day seminar that takes an in-depth look at a chosen theme of history or heritage. Another popular THT initiative is the annual Site Seminar, a week-long visit to places of historical importance where every participant is expected to be both a student and a teacher. THT has also instituted the Tamil Heritage Trust Professor Swaminathan Heritage Award to recognize individuals who do significant work in deepening our knowledge of our rich heritage and widening the audience for heritage appreciation. Through the Indology Festival, we at THT want to celebrate not only India's culture and cultural artifacts, but also the scholars who study them. With popular interest in our heritage growing rapidly, so does the need for scholarship in a range of subjects and disciplines of Indology. This festival is our humble attempt to bring together experts from across the world to a heritage-loving audience in India and abroad. On behalf of Tamil Heritage Trust, I would like to thank each and every one of our speakers who has so graciously and readily accepted our invitation to speak at this event. We want our audiences to savor the taste of a sumptuous menu of ideas from many subjects. We have included prehistory, early history, mathematics, art, and architecture among the topics. We also have a session on heritage conservation and a panel discussion on heritage communication. In addition, the festival features contests that marry your interest in heritage with your passion for writing, blogging, or making short videos. We've been receiving entries for the contest, and the winners will be announced later in the week. Every day the program will start at 7 p.m. There will be 2 back-to-back talks by the expert speakers. The talks will be followed by a discussion moderated by the program chair. The speakers will then take questions from the audience. We request the audience to type in their questions in the chat box of the YouTube channel. Ladies and gentlemen, we're all set for another evening of ideas and insights. We hope you enjoy the program, and thank you once again for joining us today. Before I hand you over to the program chair, it's my pleasure to introduce him to you. Badri Seshadri graduated from IIT Madras and then did a PhD in mechanical engineering from Cornell University, USA. He was one of the co-founders and later director of strategy and operations of the widely popular website crickinfo.com. Badri is an entrepreneur who runs a publishing house and a software consulting enterprise. Badri has a wide range of interests. He is a sought-after commentator on TV where he shares his analysis and insights into politics and current affairs. He conducts short courses for beginners in ancient Indian mathematics. He gives talks on temple architecture and iconography and much more. Badri is also a co-founder of Tamil Heritage Trust. So over to Dr. Badri Seshadri.
Welcome everyone to Tamil Heritage Trust Indology Festival. It's my pleasure to invite you for this exciting day, which will be on prehistory and early history, which has a lot of unanswered questions, and today's speakers will try to answer some of those questions. We have 2 speakers today who will be talking about the script of the Indus Valley Civilization, which still has not been unraveled. And the other big question is that we have had so many people who have come to India what we call today as the Indian landscape. From different places, they have migrated. Who were they? What did they do? Obviously, we call it prehistory because nothing much has been written about. But if nothing is written, can we still find out more about them? Now, that is also something that we are going to see today, which is particularly about the geographical and prehistoric cultural subdivisions of the Indian subcontinent. Let's go to each of the talks. The first talk will be presented by Professor Rajesh Rao. He will be presenting about the script of the Indus Valley Civilization, computational analysis and recent interpretation. A brief introduction about Dr. Rajesh Rao. He is the CJ and Elizabeth Fong Professor, Paul G. Allen School of Computer Science and Engineering at University of Washington, Seattle. He is a co-director of the Center for Neurotechnology. He is an adjunct professor in the bioengineering department. He's a faculty member in the neuroscience graduate program at University of Washington. He's also the director of Neural Systems Laboratory. Various awards that he has received includes Guggenheim Fellowship, Fulbright Scholar Award, National Science Foundation Career Award, ONR Young Investigator Award, Sloan Faculty Fellowship, David and Lucille Packard Fellowship. Along with his interest in neurotechnology, which is his current major interest, Professor Rajesh Rao has spent considerable time on the script of the Indus Valley Civilization, and he has collaborated with one of the greats in this field, Dr. Airavathan Mahadevan. Let's look at a brief abstract of what Dr. Rajesh Rao will be presenting. We are all aware that nearly around 4,000 years back, and a little older than that, people who were living in what is now Pakistan and northwestern India, that's the region that we call as the region for Indus Valley Civilization, IVC. There, we have found short sequences of symbols on seals, tablets, pottery, and other artifacts. These Indus seals constitute, all these things put together constitute Indus script. It's one of the last major undeciphered scripts of the ancient world. We still don't know exactly what is there in it. Deciphering this has significant ramifications for the way in which we view the prehistory of Indian subcontinent. Dr. Rajesh Rao will focus on the research aimed at analyzing the Indus script using computational and statistical techniques. This kind of an analysis does not address the issue of interpreting the symbols, but will try to bring out the syntax of the script and allows a comparison with other scripts that are encoding natural languages. His talk will also focus on the constraints imposed by the syntax and artifact use could suggest possible interpretation. For example, he will talk about the class of fish symbols in the script. Most of the Indus seals carry the fish symbol. He would look at what this could mean, and from there on, drawing forth, there could possibly be interpretations on what these Indus seals may mean with respect to trade. Are they, in some sense, some kind of a monetary system, like a pre-coinage system for economic transaction, allowing for rapid generation of tokens, tablets, sealings, etc., to facilitate exchange of certain fixed amounts of goods, grains, animals, and labor. So this talk will focus on the script, bring about a certain understanding of how to interpret these syntax, and also come up with certain interpretations related to what those seals themselves could mean. So that will be the first talk for us. I welcome all of you once again to this talk, and we will move on to the first talk, which will be presented by Dr. Rajesh Rao.
Hello everyone, my name is Rajesh Rao. I'm a professor at the University of Washington in Seattle. And I want to take you on a journey to a 4,000-year-old civilization and talk a little bit about our efforts to understand the script of the civilization. So 4,000 years ago, there were famous civilizations such as the Egyptian civilization and the Mesopotamian civilizations. As most people know, the Egyptians were building great pyramids around this time. The Mesopotamians were also building ziggurats, and there were kings, there were wars, and so on. If you now move to what was happening in the South Asian area, there was also a civilization there. In fact, it was even larger in terms of the area than the Egyptian and Mesopotamian civilizations. It occupied almost 1 million square kilometers. And this civilization was the Indus Civilization. It was basically flourishing around 2600 to 1900 BC. And some of the main sites are shown here, Harappa, Mohenjo-daro being the most prominent of them, and then Lothal and Mehrgarh being two others. And in the civilization, what's surprising is that despite the very large size, there is no archaeological evidence for any grand buildings such as pyramids or huge temples. There's even no evidence for these people building palaces, for kings and so on. What we have evidence for is very well laid out cities, which had amazing, sewer systems and water conservation systems. These systems would put, even some of our contemporary systems to shame. These people did not build, big palaces, but they did they did actually design these smaller objects. And so as you can see here, these are some of the iconic objects that you will see when people talk about the Indus civilization, also called the Harappan civilization. We actually do not know, who these people are. Is the person on the left a king, a priest, or a priest king? We don't know who the lady is in the middle. She's been called the dancing girl, and we don't know who the deity is. Looks like a horned deity, but we don't really know who that is. And unfortunately for us, we don't know anything about them because we have not been able to decipher their script. Yes, they did have a script. Here's an example of their script on these tiny seals. And as you can see, the seals have the script at the top, along with an iconic animal, in this case, this imaginary animal, a unicorn. But we actually have we actually do not know what these particular symbols mean. And these symbols are found not just on seals, but they're also found on, for example, copper tablets. They're found on pottery. And somewhat surprisingly, there's also one very large signboard that was found in the ancient Indus city of Dholavira in Gujarat. And again, despite being a large signboard, this particular, the inscription there is, again, not a very, very long inscription. That's one of the issues that we have in terms of deciphering the script. So the big question, of course, is, what do these symbols mean? Because if we can read these symbols, we'll learn more about this ancient civilization. This actually is one of the last major undeciphered scripts in the world. And so there's three different hypotheses that people have considered. The first one, which is a provocative one, is that the script does not even encode any language. So the idea here is that the symbols in the script are analogous to the symbols you find in shields, for example, or symbols that you use for indicating things like traffic signs and so on. A second hypothesis is that the Indus script encodes an Indo-European language. So if you look at this map of India, you'll see that most of North India, as well as East and Central India, the language spoken in those languages spoken in those regions of India constitute are part of the family of Indo-European languages. And then finally, the third hypothesis is that the language encoded by the Indus script, the Indus people perhaps spoke a Dravidian language. So if you look at the map of India today, what you'll see is that the languages in South India, for example, Telugu, Kannada, and Tamil, they're part of the family of Dravidian languages. And then, interestingly, if you look up north towards Baluchistan, in current present-day Pakistan, you'll find a large group of people who actually speak a Dravidian language called Brahui, and that's somewhat surprising, and that's led people to suggest perhaps the Indus people were also, speaking Dravidian languages. So which of these, three hypotheses is correct? So one of the issues, of course, three of the issues I would talk about here, three issues that come up when you try to decipher the Indus script, is that first, there is no Rosetta Stone for the Indus script. So by Rosetta Stone, we mean that an artifact that contains an inscription in the Indus script, as well as the same content in a different script that has been deciphered. For example, the Sumerian, the cuneiform script and the Indus script. There is no such artifact, or at least there have not been, no artifact has been discovered yet that's analogous to the Egyptian Rosetta Stone that was instrumental in deciphering the Egyptian hieroglyphics. Secondly, as we've just talked about, we don't really know what language the Indus people spoke. And finally, also, as I alluded to earlier, most of the texts, pretty much all the texts actually that we have that have come down to us through the ages, these texts are all very short texts. So texts that are on average maybe 4, 5, or 6 symbols long, and these are typically on, as I said, these seals or tablets. So one thing we can do, though, is even if we cannot decipher the script yet, one thing we could do is start to understand things like the syntax and also, in this case, direction of writing. So, for example, if you look at these two impressions of seals, the seals are actually, they show the reverse image, and this is the impression of each of the seals. What you'll see is that on the left-hand side, there is a compression. It's as if the scribe who was writing the symbols of the script here ran out of space, and therefore had to either compress the symbols on the left-hand side, or even put one of the symbols down below because they ran out of space. So this suggests that the direction of writing is actually right to left. And there's actually more than just this piece of evidence. There's also evidence from pottery. In pottery, people have shown that if you look at the inscriptions that are on pottery, you can see that some of the symbols that have been written on the right-hand side have been overwritten by another symbol, the next symbol on the left-hand side, which again suggests that the direction of writing was from right to left. What other things can we do besides just trying to, before we actually decipher the script? One thing we did was to look at patterns in the Indus script. So let's start by looking at patterns in language. So if I give you the letter Q, the symbol or the letter Q in the English language, what would you predict is the next symbol? So if you think about this, this is something that anybody who has learned English can predict, right? Most of you probably predict the letter U. So Q is typically followed by the letter U. And now if I ask you to predict the next letter, now you have several choices, right? So you may have predicted, for example, the letter I, so QI, QUI, and then you have quiet, and then you have quick and quiet and so on. The other possibility for Q and U, the next letter would be E, for example. So you would have queen or queer or quell, for example. One thing that you will not do is to predict something like the letter B, right? So you wouldn't say that the next letter would be a B or a C or a D. And so the question you might ask then is, what about the Indus script, right? So if you look at the Indus script, you'll see a similar kind of pattern. So if you look at all the texts that we have now of the Indus script, many of the inscriptions, the texts, they start off with a symbol such as this diamond-shaped symbol. And this is typically followed by these quotation marks like symbol. And then after this, this sort of a prefix, what you find is a cluster of symbols that have signs such as these fish-looking signs. So if you look at this sign, it looks like a vertical fish-like sign, followed by other symbols as shown here. What you will not find is this particular quotation marks like symbol being followed by, for example, these human-like sign or an arrow sign and so on. And then finally, there's also very typical enders. So ending the text are these symbols. For example, this symbol is called a terminal sign. So this symbol looks like a jar, like a double-rimmed jar. So this jar sign is also one of the most frequently occurring signs in all the texts that we have so far. So this seems to suggest that there is some kind of regularity. There's some kind of a pattern also in the Indus script. So what we did, we wanted to quantify the patterns. So what kinds of regularities are there in the Indus script? So we used a computer to learn a statistical model. So this kind of a statistical model is also called a Markov model, where we use the computer to essentially count the kind of frequencies of what symbols follow a given symbol. So we're essentially looking at the probabilities of each of the symbols that can follow a particular symbol. And once we've done that, then we have a quantitative model of the sequential structure, you can say, of the Indus script. So what do we do with that? So once we have a model, a computer model, what can we do with that? So for example, if you had a monkey typing on a keyboard, right? So you might end up with some garbled set of letters that look something like this, right? So if you now quantify the amount of randomness, right? So you're looking at the probability of symbols following a particular symbol. In this case, in these kinds of random sequences, any symbol can follow any other symbol. So the entropy, right, is very high. So entropy is a quantitative measure of the amount of randomness in strings. And so we can say that this kind of a string where you have any symbol could follow any other symbol has a very high entropy. Now, the other extreme, if you have, for example, the case where, this has happened to me too, where you sometimes, as you're typing, you may have dozed off, for example, and you have your finger on a key and it just repeats the same letter, right? So in this case, it's a highly regular set of highly regular string, and there is no, quote unquote, randomness right here. So in this case, as you might have guessed, this kind of a rigid sequence has very low entropy. So these kinds of strings would have very low entropy. Now, what about languages, right? So scripts that encode languages. Well, as you might have guessed, languages, scripts that encode language have an intermediate level of entropy. So they're neither highly, random, nor are they very, very rigid. So they're right in the middle somewhere. So now you can ask the question, what about the Indus script, right? So this is where our computer model comes in. So we used our computer model and we applied it not just to the Indus script, but we also used it to quantify the entropy of many different kinds of scripts and strings. And here's the result. So as you can see, at the very top, as you look at the very top, you have very high entropy here. You have very low entropy at the bottom, and that's the y-axis here. So it's plotting the normalized block entropy, which is the entropy of strings of increasing lengths. On the x-axis here is the sequence length. So three sequences of length 1, 2, 3, 4, 5. So increasing the length of the string, and you're asking, if you look at all the strings of that particular length, that set of all strings, how much is the entropy, or how much is the amount of randomness? And the main result that we got was to show that the Indus script, so the amount of randomness or regularity in the Indus script falls right in the set of all the linguistic scripts. So, for example, scripts that encode Tamil, English, Sanskrit, Tagalog, Sumerian, the cuneiform script in this case. So they're all right in the middle. They have intermediate levels of entropy as you increase the length of the sequence. Whereas if you look at other strings like DNA and proteins, so sequences of DNA and proteins, you'll see that they have very, very high entropy. So they have a lot more randomness or flexibility in terms of what symbol can follow what a given symbol. Interestingly, a computer program, this was actually a Fortran program, so nobody uses Fortran anymore, but you can still compute the entropy of these programs. And so what you find there is that it's actually a little less. So the entropy of computer programs is a little less. So it's more rigid, I guess is another way to look at it, than the linguistic scripts. So So one other thing you can do with this computer model that we have is to look at patterns of things that are unusual. So for example, just to draw an analogy here, if I give you a sentence in the English alphabet, so all human beings are born free and equal in dignity and rights. So that's been translated here, and this is the same content, but in Dutch. So it uses the same letters of the alphabet, but what you'll notice if you do not know Dutch is you will think that some of these combinations of symbols are very, very unusual, right? And that's natural because you have not learned Dutch. So interestingly, our computer model detects that certain strings or certain texts are actually quite unusual in the sense that they have a very low probability of being generated by the computer model that we learned from the text. And why is that? Well, for example, in this case, if you look at the very first text, what you'll find is that it repeats this most commonly occurring sign, this jar sign, which typically ends an Indus text. In this case, it's repeated. So there's one jar sign following the other, and this never happens. Almost never happens in the Indus text. Similarly, for the other one, also there are very unusual patterns in terms of what symbol follows a given symbol, and so it turns out that these texts were actually not discovered in the Indus Valley. They were actually discovered in faraway lands. In fact, they were discovered in archaeological excavations in the Middle East. So, for example, in present-day Iraq. And so the underlying idea is, how come these seals ended up there, right? And in fact, some of these seals even look very different, even though they use the same script. One of them is circular, the other is a cylinder seal that has been unrolled here. This is the impression of the seal. So they do look different, but they're using the same symbols, right? So what can we say here? So one of the things that I have not told you yet is that the Indus people were very, very enterprising. So the merchants of the Indus Valley were probably the very first kind of global traders in some sense, right? So they actually traded not just with other cities from their city, but they actually had trade going on with civilizations and people in the Persian Gulf, in Dilmun, which is present-day Bahrain, and also in the Mesopotamian civilization. And there's even written cuneiform texts that talk about a land called Meluha, which people think corresponds to the Indus civilization. And so one of the hypotheses here that our computer model suggests that people have suggested before is that perhaps the Indus merchants were using their symbol system, their symbols to represent maybe a different language, a language that was useful in these other faraway lands where they were conducting trade. So the same script was perhaps being used to encode different languages. All right. So at this point in time, you might be wondering, is there any hope for actually reading these symbols, actually making sense of them, making sense of the meaning of these strings, these texts, right? So I'll just give you a brief overview of what we have found. This is not just the work that I've done or my collaborators have done, but even colleagues in the field of Indus script research. So one of the main methods that people have used to understand or gain or infer some meaning, right, or suggest meaning to some of the symbols is the Rebus Principle, right? So, for example, if I tell you to represent a word such as belief using pictures, how would you do that, right? So if you think about it, what are the pictures you can use to convey this very abstract word? The word belief is quite an abstract word, but perhaps you can represent it using pictures, right? So one solution, if you probably already thought of this, is to represent it as two pictures, so one of a bee and the other of a leaf. So you have bee leaf, which if somebody reads that, they would infer, okay, the word that the person meant was belief, right? So the Rebus principle has been used by many ancient civilizations to essentially start off with pictures and then combine them. These are called logographs. Use them to represent particular objects, but then also to ultimately combine them to form words that are difficult to convey otherwise, right? So that's one of the precursors to actually coming up with a full script for language. So for the Indus script, we're left with the opposite problem, which is you see all these symbols that look like they're pictograms, or they look like they're these logograms, right? Look like symbols, like a fish and so on, or a jar, but we don't really know what they stand for. So how do we read a string that has these kinds of pictures? So the big question there, of course, is what language should we try? So here, if you're an English speaker, you would infer the word belief, but if you speak another language, you may not infer that particular word. So what language should we try? And that comes down to, again, the question of what language did the Indus people speak? And so going back to our, the two major contenders here, one is the possibility that the Indus script encodes an Indo-European language. And so if you look at present-day India, these are languages like Hindi, and so maybe perhaps the Indus script encodes Sanskrit, right, or maybe a Proto-Sanskrit language, and that's one hypothesis. So interestingly, this particular hypothesis, there's some recent data where a very large group of researchers, headed by researchers at Harvard University, showed that if you analyze ancient DNA from skeletons in many parts of South Asia and also Central Asia and so on, it seems that the DNA analysis seems to suggest that there was a migration of Indo-European language speakers, but that happened only after 2000 and probably 2000 to 1000 BCE is when they suggest that this happened. Whereas we've already seen that the Indus civilization flourished quite before that. So 2600 BCE or even before that, there's evidence for the Indus civilization. And so there seems to be a mismatch there in terms of the language when people may have been speaking that particular language versus when the Indus civilization flourished. The second hypothesis, as we already mentioned, is that perhaps the Indus people were speaking Dravidian languages. And so the hypothesis here is that there were people speaking Dravidian languages all over the Indian subcontinent, but then right now you only see them in pockets, such as Brahui in Baluchistan in Pakistan, as well as in central India. You see pockets of Dravidian-speaking people, such as Gondi, and in the eastern part of India, Malto and Kuruk, and so on. So if this is a hypothesis you would like to entertain, then where does this lead us, right? So many researchers have actually tried to use the Dravidian hypothesis and try to interpret the symbols. So one of the most famous ones, I think, is the interpretation for the fish symbol. So here's an impression of an Indus seal. You can see that it has basically these tally marks, 7 of them, followed by the fish symbol. And these are examples of other fish symbols you'll see in the Indus text. So is there a way to interpret this fish pictogram using, for example, a Proto-Dravidian kind of reconstruction of language? And so one of the first people to suggest this was Father Henry Heras, back in 1953. And Father Henry Heras suggested that the Dravidian word for fish is mean in many Dravidian languages and also in Proto-Dravidian. And mean also sounds like the word for a star. And so he suggested that this combination of symbols of 6 strokes followed by a fish sign, if you read that in a Proto-Dravidian kind of language, it would stand for aru mean. And that in turn is a word that we find was used if you look at Dravidian language, especially Tamil literature, you'll find that as a word being used for the star constellation Pleiades. And similarly, some early Russian researchers, led by Norisov, suggested that this sequence of symbols, so 6 followed by the fish sign, the jar sign, and the human sign, may stand for Arumin Kadalan, which is another very old word that you'll find in old Tamil literature for Skanda or Muruga, the god Muruga. So these are really intriguing suggestions, which seem to be something that perhaps you can build on. So you can ask, can we take this further, right? So this is a promising beginning. Can we take this further? So one of the leaders in the field, Asko Parpola, has suggested in his book, published in 1994, several other additional readings. So for example, 7 stars, as shown in this seal impression, he suggests stands for Yelumin, which is, again, Yelu is 7. And Yelumin is, again, a word used to represent Saptarishi constellation, or the Ursa Major constellation. And this is, again, in old Tamil literature. Similarly, he suggests that when you have a little symbol on top of the fish sign, he interprets that as roof, and so that stands for Main, which is, again, a word that has been used for Saturn in old Dravidian languages. And then also when you have a dot inside the fish, he interprets that as Pottumin, which is, again, a star constellation, the Rohini star constellation, or Alpha Tauri. So these are all very intriguing. You might ask, okay, what does this have to do with seals, right? So the suggestion here that Parpola makes is that the seals represent, the inscriptions on the seals are all names. So names of the merchants, which is a typical kind of function of seals. And so they denote ownership of property. So when you stamp something, maybe they denote that the property belongs to a particular merchant. And so when the goods were sent from one city to another, or one merchant's place to another merchant's location, then they would have these stamps. And so it makes sense in terms of the names being what these inscriptions represent. And further, Oscar Parpola says that a lot of South Indian names have to do also with horoscopes, and horoscopes in turn are based on the stars and so on. And so he makes that connection also in terms of why he thinks these symbols represent names that are based on horoscopes and astronomy. And so one of the problems with some of these interpretations is that they have to account for why there's particular patterns. Like, for example, these fish signs seem to cluster together, as shown in these examples over here. And so so the fish sign by itself is probably not going to represent a syllable, for example, like pa or ka or things like that. And so because you can't really have them repeated multiple times with, if you have syllables such as that repeated, you might get pa, pi, pu, and so on, which doesn't really make sense in terms of linguistic constructs. In terms of Parpola's interpretation, he says perhaps they represent combinations of astral configurations or different constellations all put together in one name, which is potentially a possibility there. But there's a further problem also posed by the syntax of these fish signs. So these fish signs seem to obey a very rigid order. So for example, from right to left, anytime you have a particular symbol, such as the fish with these little appendages at the top, the ones on the left typically are never on the right side of that particular fish symbol. And so they tend to obey this particular rigid order. So how can we explain that? So an alternate hypothesis is that the fish signs are closely related or represent weights that are used in trade. And so if you look at the smaller Indus weights that have been found from archaeology of Indus sites, you can see that the weights are actually based on doubling. So you have weights that are 1, 2, 4, 8, 16, and so on of a particular unit weight. And so Steve Bonta suggested, going back to 1996, he suggested that the specific fish signs may stand for these units of weights. And so, for example, starting off with the basic fish sign is 1, and you go up to 2, 4, 8, 16, and so on. And one of the nice things about this particular representation is that it's a binary representation, which means that any weight can be written as a combination of fish signs without using any sign more than once. And so, for example, the weight 5 can be represented as A and C, which is 1 plus 4 is equal to 5. Similarly, 7 is 1 plus 2 plus 4, and so you have A, B, and C. So you can use these signs, And again, the signs here, will obey the order of the fish signs, right? So that's another interesting, attractive attribute of this particular interpretation of the fish signs. And finally, if you think about it in terms of, for a transaction, when a merchant is weighing a particular, item, they basically may have weights that are only used once, and then you can combine them with other weights to get any particular number, any particular amount of weight that you want. And so that's so you basically put in the biggest weight first, and then the next weight and next weight and so on. You can add them all up. You get any particular weight that you want. So it's a very economical representation of weights. And there's further evidence for this also. So the later Indian weight system was also binary, much later than the the Indus Civilization. The weight system that was used as binary, it was actually based on the weight of a rati seed. And that particular weight system is also interestingly binary. And then more interestingly, the system of weights, in the ancient world, so going far from the Indus Valley to Dilmun, which is Bahrain, in the Sumerian civilization, Mesopotamia, in Egypt, there was a unit of weight known as the mina, and the mina was used in several of these civilizations. And of course, using the rebus, the fish sign that we read, we previously read that as mean, and you can see it's closely related to mina, right? So the unit of weight that was used in the ancient world. And so Brian Wells, who's another major researcher in the field, has suggested this particular set of weights that associate with each of the fish signs based on his analysis of the frequency of the fish signs and the frequency of weights. He suggests that the basic fish sign has a unit of 6.9 grams, and therefore you can have units such as this. So he interprets this slash as being a half, so half, and then 1/3, 1/4, and so on. Similarly, he suggests that the fish sign with a dot in the middle is actually twice the unit, and then 4 times would be the one with these 2 horns, like a horned fish, and so on. And so he's come up with this particular set of interpretations of fish sign to weights. So each fish sign has a particular weight associated with it. And interestingly, if you look at the unit that is twice the basic unit, 13.4 grams, it's actually very close to the 13.6 grams, which was an international standard in other civilizations like the Dilmun civilization, Ebla civilization in Syria, Egyptian civilization, and so on. They were using this particular unit, 13.6 grams, which is very close to the fish sign with the dot or the mark in the middle, which is what Brian Wells suggests corresponds to 13.4 grams. Finally, I'll end with some of the work that I've done trying to relate some of these ideas to the economics of the civilization. So as we already seen this particular impression of a seal before, many of these signs, the fish signs have tally marks or numerals in front of them. There's basically 7 is what you would infer from this set of tally marks. There's a whole bunch of other symbols also that have tally marks in front of them. For example, this symbol here, or this diamond-like symbol, this is actually a V-shaped symbol that looks like a jar, which is preceded by 4 tally marks, right? And so a bunch of these particular symbols, these particular texts were found in these miniature tablets, the 3-sided miniature tablets in the site of Harappa several years ago. And so one of the things that you can ask is, what can these tokens or these tablets be used for? Why were they generated? And many of them are replicated. They're not unique. So they're probably not just names, but they were replicated almost like currency or coins, right? And so if you draw the parallels with other contemporaneous civilizations like the Elamite civilization in Iran and the Sumerian civilization in Mesopotamia, what you'll see is that at the same time as the Indus people were using these miniature tablets and so on, these other civilizations were using tablets also, but more for accounting. So they were using it to count the rations that were being used for laborers and workers. So for example, here you can see these impressions that are made that look like tally marks followed by a jar sign. There are these symbols that look like grain, so stalk of grain like barley, for example, and also these kinds of marks that are like tally signs. And so basically, people have interpreted these proto-Elamite and proto-cuneiform tablets as encoding the amount of grain or measures of cereal, grain, oil, and things like that that were being used to provide to the laborers or worker who were engaged in work for a particular employer. And so the suggestion here is that perhaps these miniature tablets, these tokens, were essentially ration tokens or economic tokens that were helpful in the administration of labor. So for example, here, each of these would denote some particular measure, like a unit of measure, followed by the amount of how many units were being used or provided to a particular person. And in fact, interestingly, Brian Wells has shown that there are pots. So these are pots that are currently in Purana Killa in Delhi that were excavated from Harappa. And he's shown that the inscription on these pots actually have the similar kind of inscription as this tablet. So here's a tablet that has 3 followed by the jar sign. And similarly, this pot has 3, the numeral 3 followed by, or 3 tally marks followed by the jar sign. And some of these bigger ones have more of these tally marks. So the inference here is that these numbers denote volume, right? And so he came up with an estimate based on the size of these pots that the basic unit, this V-shaped sign or this jar sign, is a volumetric measure that is about 40 liters. So 40 liters is what he inferred this to be based on the size, the diameter and the height of these jars. And so our particular inscription here would correspond to essentially something like 120 liters. So that's kind of an accounting that one might be, the employer of a particular business might be taking into account and using these tablets to either give it to the laborers and the workers, or to retain it as an account of what happened. And so we suggest that the seals themselves are also perhaps an innovation, an Indus innovation, to make it more efficient, make this generation of economic tokens more efficient, instead of having to do it individually for each of these tokens by hand. Once you have a seal, you can essentially stamp and generate many tokens as you employ people. And so, for example, when you have something like this symbol, could be 3 measures of a porter type labor. So this is a person carrying goods on a stick. We even see this sometimes in Indian villages today. And so this could be encoding that kind of labor. Similarly, there may be these kinds of symbols that look like stalks of grain. So it could be 4 measures of grain type, this particular grain type, or a different kind of grain, or a weight, as we already said. So this would be essentially quantifying 48.3 grams if you go with the reading for a particular fish symbol. And similarly, we've suggested that some of these other symbols could also denote different kinds of labor. So for example, the harrow and the man would be a farmer, or maybe there's this carter who pulls a cart. There may be this symbol, which looks like tongs, so could perhaps metalsmiths, and similarly, a bow and arrow could be related to hunting. But these are all, we got to admit that these are all still speculations. Now, one interesting find that seems to suggest that this token idea might have some merit is the fact that a Japanese team has found these kinds of tokens in a site in the Kutch in India. And so you can see that essentially it's that the harrow and a man symbol and a single straight tally mark there. So and then there's holes in here suggesting that the person, or the laborer perhaps, or the merchant, was carrying them and had them all strung up. And so it's almost like they were carrying these around in a form of currency, or a set of tokens that could be used for potentially exchange of goods, or for buying goods and so on. I'll leave you with some final ideas, which is, if you look at longer sequences than the ones we've looked at in the last few slides, they seem to have a certain pattern. So what we typically find is that there's some set of symbols that are, you can look at them as prefixes. And then there seems to be a middle part, which we're calling it medial here, after some work that's been done by Brian Wells and Steve Bonta and Andrus Fultz and others. And so the medial part seems to contain clusters of fish signs and numerals and so on. And then finally, there's also a core part of it, which is where perhaps these are the nouns that are being counted or weighed and things like that. And finally, there's a terminal sign, which is typically this jar sign or an arrow sign and so on. So we can come up with a grammar. So we can come up with this kind of a grammar that tries to mimic the kinds of patterns that you see. So as you can see here, it's like a context-free grammar from a computer science point of view that generates a prefix symbol and a medial part, a core part, and a terminal part. And each of these can be any combination of these typical pairs of symbols or more than pairs of symbols. And then the medial part might generate, for example, a fish oval cluster or a fish numeral cluster. And each of those generates their corresponding sets of symbols. So this is basically a first attempt at trying to come up with a grammar that starts to generate some of these texts. And these kinds of texts, which have this kind of a pattern, are called patterned texts. So we're calling them patterned economic texts because they seem to be quantifying weights and numbers and so on. And we can actually start to interpret some of these patterned economic texts. So if you follow the analogy from the Proto-Elamite inscriptions, typically those inscriptions have a heading that's usually the function of the tablet, and there's also some part of the inscription that has the person or institution that is involved in issuing the rations, and then there's also the commodity, what kind of item is being issued, and also the number or quantity, right? So similarly, we suggest that the interpretation that we can give to a long sequence of Indus symbols could be that the prefix might be something like the institution, business, or landlord, family, person. The medial part typically might denote the number or quantity and measures. And then the core part would be the commodity, and then the terminal part is something about the function of the seal in terms of what the seal is being used for, or the token is being used for when it's being impressed onto a tablet, for example. And so these kinds of ideas, have been discussed in this paper down below, which you can find on my website. And finally, there's one particular set of texts. So the pattern texts are what we can quantify or characterize using this kind of grammatical rules. But there's also what are called complex texts. And these may actually encode linguistic constructs. That's because, for example, if you look at the Dolavira signboard, the Dolavira signboard does not have any numerals or fish symbols. And it has some interesting regularities here also, such as these sort of chakras like signs, these circular signs that look like wheels. And so the suggestion is that there are lots of these texts that are not characterized by this kind of a grammatical set of rules, and those might potentially denote linguistic constructs, which would also fit in with the, if you recall the graph that we had, that the Indus script seems to have regularities in it, and it seems to have regularities that are in line with linguistic scripts. So this particular set of texts would definitely benefit from further studies. So let me conclude by just showing you some of the kind of historical decipherments that we've had in the past. So the Egyptian hieroglyphics were deciphered in 1822. The Mesopotamian script, the cuneiform script, was deciphered in 1857. And the most recent one, the most major recent script that's been deciphered is the Mayan script in the 1950s. And then now we're in the 21st century, and we're still unable, or at least we don't have a very good idea of what the Indus script represents, what kind of language it represents. And so the Indus people are still silent in some sense. And so why is this important? So the Indus people are ancestors, and they're not just the ancestors of South Indians or North Indians or Pakistanis or even South Asians. The Indus civilization belongs to all of humanity. So I think it's our responsibility to collaborate across disciplines, across boundaries, both regional boundaries and national boundaries. We need to collaborate to decipher the script so that these people can speak to us again. I'll end with that. And here are some acknowledgements. I'd like to thank all my collaborators and all the great colleagues that I've interacted with. And also, I'd like to pay special tribute to a colleague and collaborator of mine, Iravathan Mahadevan. So Iravathan Mahadevan was one of the pioneers in this field of Indus script and decipherment. And so we miss him, but also we really value his contributions to the field. Thank you very much.